Hey TechKnowStuds, this right here is a transistor. It's just a mini switch. It doesn't hold any information. However, we figured out how to add something to this to turn it into a memory cell. So in this lesson, let's take a look at a memory cell and how we can take a transistor and turn it into something that can actually store data. Here's a diagram of a transistor. Right here we have a semiconductor material that can either pass electricity through it or not pass electricity through it, depending on what we put into the gate. We apply a power to this. And if we were to put some voltage into it, we'll represent it as 1, it may allow power through here. Or a 0, meaning the electricity is off, then it won't allow power to go through and it will stop the flow of electrons. Now that's not the only type of transistor there is out there, but that's just one example. You can think of this as like a button right here. So imagine if I were to press this, it would complete the circuit, allowing the electrons to go through it. However, if this is not depressed, then electrons are not going to be able to pass through this circuit. So essentially this is a button, or once again, a switch. These transistors or switches, we can create in different ways to do different things. And we call this some sort of logic to it. So what we do is we apply power to this side of it right here. And if we apply, let's say we apply power, we're going to just represent power at the top here as 1. Maybe it allows flows of electrons, and so we get 1 out of this. Or perhaps what we do is we apply a 0 to it, and then it will stop that flow of electrons. There's also different types of transistors. So there are some transistors that if we apply 1 to it, it will stop the flow of electrons, or we can apply a 0 to it to allow a flow of electrons. But essentially, we can make these switches do different things depending on what we want to achieve out of it. When it comes to these transistors themselves, there's really not a mechanism to store data in a transistor. That is, when we press this button, it's either going to allow electrons to flow or not allow electrons to flow, depending on what kind of transistor it is. But essentially, as soon as we take away the power from this, the circuit, the switch is no longer going to be operatable. It's not going to really store any data in a transistor itself. In the 1960s, somebody took a transistor and created a memory cell from it. A memory cell stores a single bit of information. So what we have right here is we have added a charge trap in between the two layers here. So we have a gate that we apply power to, and then that changes the state of this charge trap down here. And that charge trap is something that's permanent, that it doesn't go away. So now we can either permanently allow the flow of electrons or stop the flow of electrons based off the state of this charge trap. Now we have something that stores memory. So here's a little different way to look at this. If we apply a 1 to the gate right here, that state gets saved in this charge trap. And now, even if we take power away from it, that state still exists. Now, if we want to figure out what bit this is it a 1 or a 0, we just apply power to this side, and we are going to get a 1 or a 0 on the other side, thus creating a memory cell.